Hi, I like to present you, what is the first draft for the project J, okay? It's going to be about a dedicated processor, which means that you will have to consider data path and control unit as the main blocks in the circuit. It's just an extension of the plan C2, This is plan C2, okay? Again, so in this way you will have another opportunity to use this plan and see what happens with the several blocks. So what I'm proposing you is something like this, you see? A circuit that can be very well named like pulse generator. It is going to have a start and a stop button and then some other parameters to program the waveform that it generates, okay? It's about the train of pulses. And on the other hand, you have an oscillator clock in, and the oscillator perhaps is something like this, a 50 megahertz crystal oscillator, from which you will extract all the frequencies required for this problem. So here you are, the pulse output that is going to look like this, a sequence of pulses, and then some additional controls, or some additional outputs that is going to give you an insight or when the frame of pulses is going to end. Okay, so this is the pulse out and end of frame. And this means that when you click the start button, the frame starts. So for example, something like this, one pulse, then nothing, and then 3 pulses, nothing for a while, and then 2 more pulses, and this is the frame, okay? For example, 16 different binary values in between ones and zeros. Something that, if you like, you can go and program like this. You see, you have that the P, this input vector, is going to be for defining the sequence of ones and zeros that are going to be sent from the pulse output, okay? You will configure the frame pattern, okay? So this P pattern configures the frame. And in this way you generate the frame, and then when the frame ends, you go and generate an end of frame signal. That way. And the system can be organized like this. After a given delay, the machine repeats that frame, you see, another time. 1 1, 3 1s, and then nothing, and then 2 more 1s, and then after this second frame, another end of frame pulse. Something like this, okay? Is that right? So, for example, the final feature that you can see here is that this delay may be programmable. For example, 0 0 0, for example, here you have an input that is delay 3 bits, and in this way you can say something like this. You can organize the delay time. For example, 0 0 0 means that a single frame is generated, okay? In this way, you don't have to stop the signal, because you start, and the start becomes a trigger button. You trigger the button, and the frame is generated for a single time, and then nothing else. The end of pulse, and that's all. You have to click again to trigger again another frame sequence. But if you are configuring 0 0 1 and down to 1 1 1, for example, you may say that the delay time is something like from 1 second to 7 seconds. So that, depending on the binary code that you have here in delay, you have the possibility to have this kind of waveform periodical, right? A periodic signal. All the time the frame, 7 seconds later another time the frame, and another time the frame, this way. Okay? And so finally there is this idea of a stopping. If the sequence is periodic, we'll never stop unless you click again the start. So this is why you call that the start and the stop button. If you click it again, the machine will stop, but not stop automatically. You will wait until the frame is finished. That's another feature which is in some way difficult to grasp and consider. You see, you click a stop, but the machine do not stop immediately, as if it were a clear direct or something like this. No, like this. You click a stop, and if you are in the middle of the delay or in the middle of the sequence, all right? The machine continues for 7 more seconds or 3.5 seconds more. Then there is the generation of the last frame, and then yes, after the last frame you stops. All right, so this is a kind of digital system that can be interesting for finishing this chapter 2 on sequential devices. Okay, just a function generator, and you can imagine that the thing like this can have many applications on many fields. And finally, for example, the last idea here is the frequency of the pulse generated. All right, for example, let's say that all the pulses has the same duration, and this duration, for example, is 1.25 milliseconds. So this has been the presentation of the idea. It's an initial draft. It means that you can have this idea, or some customer give you this idea, and you put that in paper for half an hour, some pictures, an idea of the symbol and how it may work, and now is your turn. Because if you ask me, you know, to tell you the truth, I have not the slightest idea of how difficult is the problem. So that's the point. Not even me knows the answer. That's a real problem. That's a real project for you to solve. And so I guess that you first of all you have to go in solving some examples of data path control unit devices in P8, and then you can very well, and also some problems in the collection, and in this way you can very well understand what is behind this architecture of an advanced digital circuit, and try to apply it here in this specific application, right?